My name is Douglas Wightman. I work for Adaptive Computing, and this session is going to be on continuous and future scheduling, focusing on two areas, reservations and preemption. Now I know last moab.con I went very in depth on reservations. This is going to cover something different. I don't want to repeat the same subject. And then after that, we will talk about preemption. First off, reservations will cover why they make Moab the greatest. And I really do think that they make Moab the greatest. Why and how Moab uses them, how to make them work for you, and then what to avoid when you're using reservations. Then we'll talk about preemption. Does preemption work for you on your site? It doesn't work on all sites. It doesn't fit into policies, doesn't work with applications. We'll go into that. We'll talk about how Moab implements preemption. There are multiple ways of doing it, and we've chosen one way of doing it. How to configure and what to avoid with preemption as well. So, reservations. Reservations are awesome. That is how Moab achieves such high utilization on a cluster. Moab uses its patented reservation engine to ensure that the right jobs are going to the right resources at the right time. Reservations ensure that low priority workload does not interfere with high priority workload. It helps facilitate start time estimates so that users know roughly when their job is going to start. Reservations are dynamically scheduled, they're dynamically allocated. Moab will move them around all the time, it will store them, create them on the fly, all over the place. This is the mechanism that Moab uses to get utilization high and to ensure that the SLAs for the site are being met. So just very basic, what is a reservation? A reservation has three aspects. One is being reserved. So in most cases, it's going to be a machine, a computer. It could be the number of processors. It could be software licenses. It could be memory. It could be disk space. So that all is what is being reserved. Second, when is it reserved? What's the time frame? It could be infinite. It could be 1 minute. And then finally, the access control list. For whom is it being reserved? Can be empty, which means it's reserved for nobody. Nobody can get in there. Or it could be open. It could be open for anybody. That is basically the three aspects, the three attributes of a reservation. In a lot of ways, it works the same way as a hotel, for example. Somebody calls up, they need a reservation in a hotel. Well, you ask, when do you need it for, and you reserve the room. That's how you make sure that you're not going to get two guests in the same hotel room on the same night. Well, Moab does the same thing, uses reservations to make sure that you're not going to have two jobs on the same processors at the same time. Reservations are lots of different ways that they are created. They can be created manually in two different ways. The first, one-time reservations from the command line. That's just using the MRCC calculator. If you have periodic or standing reservations, those are defined in the Moab configuration file. And then there are maintenance and special projects, resource ownership type reservations. Maybe you want to ensure that this user always has access to these nodes, preferential access, or things like that. So those are reservations that administrators will create manually. But Moab also creates reservations automatically just to pack as much into the system as it possibly can. So every active job on the system has a reservation. This is done, as I mentioned before, to make sure that jobs don't run on top of each other. Idle jobs, jobs that aren't running yet, will get reservations out into the future. So Moab will map the system out into the future in basically a multi-dimensional graph. It's not just 3D because you have more resources you have more than just processors. You also have memory, you have licenses, you have all these other things that Moab has to map. So it's a multi-dimensional map going out into the future across all the resources on the system. Moab places the reservations down to ensure that the right jobs are going to the right places. Then, once the high priority jobs have been given their reservations, you've got empty slots. That's where Moab backfills. Now, because Moab uses this mechanism of giving the high priority jobs a reservation, it ensures that when a low priority job starts in front of a higher priority job, it's actually doing so without affecting that high priority job at all. Moab knows when the soonest that high priority job could start. And the soonest it could start is 10 minutes. There's just nothing that could be done to start it sooner than 10 minutes. The nodes it needs are busy, whatever. It's a big job. Can't start for 10 minutes. Well, that's 10 minutes of idle time that you're waiting. So using reservations, Moab can pack jobs in there to ensure the high priority jobs are getting on as quickly as possible, but the low priority jobs are getting on in between. So Moab creates these job reservations automatically. Creates them, destroys them all automatically without users having to do anything. They just submit their jobs. Moab places the reservation there. But there are some policies you can put into Moab to configure how Moab creates these reservations automatically for jobs. So the first is reservation policy, and the second is reservation depth. So let's talk about reservation policy. There are 3 reservation policies inside of Moab. The first is highest. This means the highest job, once a job reaches the highest position in the queue, it will get a reservation and it won't let go of it. So even if another job is submitted that ends up being higher priority, and this guy hasn't started yet, this guy still isn't going to let go of his reservation. Once you get to that top spot, your guarantee is start time. Current highest means that Moab will give a reservation to the current highest job, highest priority job. But if another job comes along and ends up being higher priority, it'll bump that guy. That guy will lose his reservation, and only the highest one will get it. The third is never. You just basically never give an idle job a reservation. Only active jobs ever get reservations. So why would you want to use each one of these? Highest. I think it really comes down to what your users are expecting. If your users are very picky, they're watching the queuing system, very demanding, in most cases you might want to use highest. Otherwise you may be getting lots of calls saying, I had a reservation and I lost it. What's going on? Why is this user higher priority than me? So by doing highest, once a job gets to that top spot, users can breathe easy. They know their job has a reservation. They can go on with their life. Current highest is useful when you have probably a lot of turnover at the top. Users aren't watching their jobs as closely, and you just want to make sure that the highest priority job is getting in there as quickly as possible. In that case, that's probably the time when you use current highest. Never, that's probably if you just wanted to increase utilization by an enormous amount. So if you think about it, if Moab is mapping out this cluster into the future, and you don't allow any idle job reservations into the future, then that means that the whole cluster is open for backfill. So at that point, instead of creating idle job reservations in the future, Moab just has this big old window that it can now fill up with jobs. So if utilization, you wanted to increase it beyond what it is, you could use the reservation policy. You can also configure how many of the top jobs will get reservations. So by default, it's 1. Only the highest priority job in the queue is going to get a reservation. And in most cases, that works out just fine. It makes it so that the backfill window is sufficiently large for Moab to continue to stuff the lower priority jobs onto the system. That works pretty well. But in a lot of cases, you may have special projects, you may have power users or whatnot, and you want to give preferential access to reservations to this group. And in that case, you can increase the reservation depth site-wide or for all jobs that make it to the top or just on a per QoS basis. So the reasons to increase reservation depth, well, if you think about it, the more reservations you've got on the system, the easier it is to predict when a job is going to start, because you've mapped further out into the future. So Moab can make smarter guesses about when a job is going to start. So if you have users who are really just pounding show start, really want to know when their jobs are going to start, increasing reservation depth can make that more accurate. Decreasing reservation depth increases system responsiveness for the most part. When there are more reservations on the system, that means Moab has more work to do. There's more scheduling to do. Every reservation requires Moab to go out, ensure exclusivity on the resources, make sure that nobody else is getting in when they shouldn't. So reservations add a lot of overhead into Moab. So if you're seeing slowness in Moab's, I think Trev covered earlier the ability to run the mdi-S command. You can see where Moab is spending its time, whether it's spending its time talking to the resource manager or it's spending its time scheduling. If you can see that Moab is spending a lot of its time scheduling and you have a high reservation depth, then you should lower it. But in all honesty, if you go in there, you look at the mdi-S command, you can see that in most cases, on most clusters, Moab spends a second or two. It's all that Moab spends scheduling every 30 seconds by default. And you want to give more reservations out so that users can check their start times and things like that. Go ahead and increase reservation depth. So just watch Moab's scheduling time, and you can tune it to what you need for your cluster. More efficient in scheduling and handling a lot more jobs. You still want to watch that mdi-S if you're seeing a slow scheduling cycle. So there are a few things that you can do to really help Moab if you have. These are things that really go into more of the high throughput computing, but you can put in the fast RSV startup. You can stop using partial node admin reservations. Those are really expensive for Moab. If you just reserve a whole node, that's not much. But if you're going in as an admin and saying, I want to reserve 2 procs out of 8 for this user, that gets expensive for Moab. And in most cases, it's hardly ever needed. So reserve whole nodes, that definitely speeds up Moab. And then we are currently testing out this flag on a lot of different sites. And it will probably become the default. But if you are seeing Moab take a long time to start with a lot of reservations, you can turn that on.
Why do you say it can hurt reservations? Why do you say it can hurt performance if you're just advocating setting?
Oh, I'm sorry, that's confusing. You're right. This, I should have clarified on the slide. Reservations can hurt performance. These are 2 things you can do to alleviate it. The first one is don't do, the second one is do. Sorry. I need to correct that. So the first one, partial node administrator reservations, try not to do them. In most cases, they're not needed. The second one, if you do need a lot of reservations on your system, try out that flag and you'll probably increase performance. Yes?
What versions of Moab is that last one available?
This one is in, this one is in 6.0 and above. That's But again, if you're looking at your system's responding just fine, then there's usually no reason to go in and start tuning things. This is really for the sites where they need more of it. So as I mentioned, when are the times that you do want to use reservations? First, when the answer to the question, should a job run here, is it depends, then yes, you probably want to use a reservation. That can be for things such as enforcing ownership. If you have a site that has purchased a set of nodes, though I really like Michigan's way of dealing with it, it's a good way of dealing with it, but If you have users who purchase nodes and they want those nodes, then that's a good thing to use for reservation. Soft corralling of particular jobs. So, as an example, something like for users or groups where you want to steer users off to a particular section of the cluster or steer a particular projects or applications to a section of the cluster, but it's not a hard requirement. You would just prefer that they run there. That's another instance when it's a great idea to use a reservation. And of course, for one-time projects and all types of maintenance, that's exactly what reservations are. So when do you not want to use a reservation? When you're trying to do a throttling policy. That's what throttling policy is for. So if you, for example, if you want a user to not use more than 16 processors on the whole cluster amongst all his jobs, probably better to do a user CFG max proc rather than creating a reservation for that user that limits him to 16. So use throttling policies if you're trying to throttle. Hard, as I mentioned before, if it's a simple yes or no when the job should run, hard corralling of jobs, long-term single-use partitions, class use features, those are all better than reservations in those situations. So a few other reservation tips. I recommend infinite reservations. They're very useful. For maintenance and other things like that, it's very easy just to create an infinite reservation and then delete it when you're done with it. I mean, there's no harm there. And it tends to be easier to do that. There are a lot of sites who try and say, oh, well, the maintenance window should only last for 4 hours, and so I'm only going to create a 4-hour reservation. Well, the truth is, as soon as you delete the reservation once, it's going to fill up the cluster. So in a lot of cases, an infinite reservation is just easier. If you're looking for a place to put a reservation, use mshow-a. I covered this in the last moab.con. It is documented quite extensively, actually. So mshow-a is a great way to find available slots. And then finally, be careful when you're modifying existing reservations. There's a lot of different pluses and minuses and equals and things like that. So it's a good idea to read the documentation on the mrctl-m command. And another good idea is usually if you're modifying a reservation, pause the scheduler or stop it with an mskid-ctl-s, do your work, and then resume it when you're done. That way, if anything does mess up, you can always recreate it from scratch and you won't run into any problem. So before we dive into preemption, I was wondering if there are any questions related to reservation. Okay. Preemption. We're going to talk about why preemption is great and why it's not great. We're going to talk about how Moab does preemption and preemption policies. Then finally, things that you should consider if you are going to set up preemption on your site. Why is preemption great? First off, it's like a scheduler undo command. So it lets Moab go ahead and put a job on a system, and then later on, if for some reason that's not the right choice anymore to have that job running there, that lets Moab move that job out of the way. This leads to flexibility for Moab when it's deciding what to do with jobs. So it can really increase utilization. Another great thing about preemption is that it empowers users with choice. We have a lot of sites who will give preemptable jobs a higher priority, or they will give them preferential access to other systems, or they'll even let them run on nodes that they shouldn't be running on, because when the owner comes around, they can preempt those off. So it really increases the flexibility. It enforces ownership over certain nodes if you let the owners preempt and things like that with reservations. So that's why preemption is great. It can really increase utilization. It can let you oversubscribe your system in a lot of cases, as long as people understand, well, I'm gonna go ahead and submit this job, but in doing so, I understand that I'm over my allocation. So the jobs that I submit from here on out, they may get bumped off. But if they don't, great, I was able to get extra work done. So it does let you kind of increase the utilization on your system and even overall. Why is preemption not great? Well, first off, it definitely doesn't work on every job. Certain jobs, certain applications, they can't be preempted. It can be expensive, and it can just flat out not work on large and parallel jobs just because it really depends on the application. If you have applications that can be checkpointed or requeued or suspended, that's great. Or maybe you just have a bunch of users. We have some sites who they basically call them bottom feeder jobs. There are jobs that there's just so many of these jobs in the system. There's no way they'll ever get to it, but these jobs are set up to run for however long, checkpoint constantly, and then get canceled. And that's fine, because when they start up back again, they just start up right where they left off. So it really just depends on the type of application that you're running and whether or not it can be suspended. Another thing is how many resources, what kind of resources you have for your cluster. Some applications, if you're going to do suspension, you need to watch swap. You need to watch memory. You need to make sure that you're not suspending so many jobs on these nodes that you're basically just going to crash the node as it runs out of swap. So in a worst case scenario, you have a job that goes out onto a machine, it gets suspended, and another higher priority job comes along, it finishes for whatever reason, another job goes on. It basically can lead to too much swap being used and the node will crash. So you do have to watch it. That's another reason that preemption cannot be a good idea. If you're not watching the applications, you're not watching the nodes, you don't know how they behave when they're suspended, and you don't have your policy set up, it will bring down your cluster in the worst case scenario. So how does Moab do preemption? Basically two ways that a scheduler can do preemption. If you think about it, the first way is you base your decision on the preemptees. What that means is you've got a preemptor job, but you really care about the preemptees. You want to make sure that you preempt the right jobs. You want to make sure that you're preempting as few as possible because you don't want to be wasteful. Worst case scenario, imagine you have a job that is running on one machine and it's preemptible, and then you've got 1,000 node machine coming, 1,000 processor jobs coming along, and there are 1,000 available, but you need that one that job is on. So you're going to preempt that one job, even though other resources are available. So that's scheduling based on the preemptor, meaning that the preemptor is so important that you're going to schedule him as normal, regardless of the preemptees. Most sites, we have found, care about the preemptees. They care about the jobs that are being moved out of the way. They don't want Moab to just schedule a job normally, put it wherever it would have put it, and then move the other jobs out of the way. They want Moab to consider the preemptees when it is scheduled. They want Moab to, first off, preempt as few as possible. Second, they want it to preempt as low priority jobs as possible. And then use whatever resources it can get from those low priority jobs and from those jobs in order to put the job down. So, for that reason, Moab preempts based on preemptees. In other words, Moab does not go through its normal scheduling routines when it is preempting a job, or when it is looking at a preemptor and trying to decide which jobs to preempt. It goes through a separate set of routines to make sure it is not impacting as least an impact on preemptees as possible, and to ensure it's preempting the right jobs. Obviously, there are positives and negatives to this. We have a lot of sites they sometimes wonder, well, why can't I use single user with preemption? Well, it's because Moab's going through a different scheduling mechanism in order to schedule it. So, not all policies work with preemption. Because Moab is it's not going through the same scheduling routines as it does normally. So not all policies work with preemption. The way that Moab does this is, first off, it determines the feasible nodes on the system. It determines idle nodes. Then it checks to see, do I have enough idle nodes? If it doesn't, and the job is marked as a preemptor, then it will go off and it will determine the best jobs to preempt. And that way, it deviates from the normal scheduling routines. So if you wonder why maybe preemption isn't working with certain jobs, it could be because of some of the policies. I know off the top of my head, things like, I want to say single job, the node access policy single job, don't work with preemption. Certain types, so some of the node access policies, and this is documented, we have a preemption best practices guide to steer you clear of the policies that we know for certain don't work with preemption. So if you're going to do preemption, I would definitely recommend that you look at that to see if it will be compatible with the policies on your site. Yes?
Does the NDIC
It does not. It does not. The MDI-T-C, I'm sorry, capital C, is a syntactical check. So it isn't a semantic check to make sure that this policy works with this policy. Just to make sure you type it correctly, basically. That's a good question. So let's talk about the different policies that are available if you're going to configure preemption on your cluster. First, preemptee, preemptor. Who are the preemptees and who are the preemptors? So this can be QoS-based, it can be class-based. You can mark a job as a preemptee as soon as it violates a soft policy. You can mark a job as a preemptee when it has gone over its fair share allocation. So there are lots of different ways to mark a job as a preemptee. And then you can mark the preemptors based on basically the same type of behavior, QoS-based, class-based. We have some sites who will, using gold, they will let users choose for themselves whether they want their job to be a preemptee or preemptor, and they just charge differently. So if you want your job to be a preemptor, it costs more. If you want your job to be a preemptee, it's cheaper. So they kind of empower the users to make their own choices about whether or not they want their jobs to be a preemptees or preemptors. You can also have preemption be resource specific with the owner preempt flag on a reservation. So with the owner preempt flag, you can grant access to everybody into a reservation, but the owner has the ability to preempt anybody who is running in there. That way it lets sites give ownership to a particular set of resources, but at the same time, guarantee that when the owner comes along, his job can start right away. The next preemption policy is preempt policy. How do you want to preempt jobs? There is suspend, cancel, requeue, and checkpoint. Checkpoint is one that is supported based on the application, based on the resource manager. It's not used very often. The most frequent are the suspend, cancel, and requeue. So when you're deciding which preempt policy that you want to use, you have to decide, well, what does the application support? Maybe the application doesn't support suspension, in which case you need to cancel it or requeue it. Or if it's not restartable, you need to cancel it. Moab has this built-in escalation path when it is looking at preempting a job. So if a job is marked as a preemptee and a preemptor comes along and he needs to move it out of the way, if it is marked, if the preempt policy is suspend, but the job is not marked as suspendable, one will try to requeue it. But if the job is not marked as restartable, Moab will cancel it. So Moab has this automatic escalation of preempt policy to get the job out of the way. The preempt policy can be configured on a per job basis, whether the preemptee wants to be suspended or canceled, but again, Moab, because it does the automatic escalation, then in a lot of cases it can be ignored. Another thing to consider is how long does an application take to go away. So in a lot of cases you may be using a cancel or a requeue, and in some cases we've seen that it can take 5 to 10 minutes for jobs to basically go away when they're preempted. So that's something else to consider. What's the best preempt policy for the application that you're running?
Good question.
Yeah.
So you said, how does Moab know if the job is suspendable? If I'm reading that right, then once you just want to mark the policy suspendable, and then it'll just be escalated until it's canceled. Because you said, what you said earlier was you should know if you can suspend or requeue a job. You know, as you're not going to know exactly what the reason might be running. So you set it to suspend. Will Moab know that?
There's a flag on a job that
Okay,
is
the
put on
user.
the job. It's the same as in Torque. If you submit a job, you do a -R, Y, or N.
Okay. So the user
And that means rerunnable. And there is a suspendable flag that you can use as well that tells Moab, yes, this job is suspendable. So if that flag is not there, Moab knows it shouldn't even try to suspend the job.
Okay. So that's just a user responsibility that they should be aware of their job.
Yes, or using job templates or things like that, you can, yeah. Yes,
So can you set jobs as preemptee based on if they have the startable flag?
yes, you can. Using the job template. you can do it, yes.
For suspension, is there like a priority up function to open that node so it pushes back up quicker, bring the job back into production quicker, or does Moab kind of handle that?
So you mean restoring the suspended job?
Yes.
That comes down to the priority of the suspended job. So it's basically built in. When the job is suspended, Moab knows it's there, knows it's suspended, and every iteration it is still calculating its priority. That can be good and bad. You can get into a thrashing situation where you have two jobs. If you haven't configured your priorities correctly, you can have one job come along and it is higher priority, so it preempts, it suspends. But you can slowly increase the priority of the suspended job to the point where it is now higher priority than the preemptor, the one who preempted it. And he's also marked as a preemptor, so they can sit there and go back and forth forever, just fighting over this node. So Moab just looks at the priority when it's deciding what to do.
Isn't that like node application policy?
No. Moab just looks at the priority of the suspended job to decide when it can resume. And so as I mentioned, you want to avoid thrashing. You want to make sure that your priorities are set up correctly between the preemptors and the preemptees. And just so you're aware, there's a very wide spectrum of priority available to administrators. We sometimes see administrators where they will say, well, I'm going to put this QoS and give it a priority of 10, 10 for the preemptee, and 20 for the preemptor. I mean, you've got billions of numbers to work with here, so it's probably that, if you're putting things that close, you're going to get into a thrashing situation. And not only that, but it really only takes 10 minutes then for the preemptee to have the same priority as the preemptor. So you've got a wide spectrum of priority to use. I think it's, does anybody know? I think it's around 1 trillion is how high your priority of a job can get. So it's okay to set preemptees at 1 million and preemptors at 10 billion if you wanted to do it that way, or you can set preemptees at 0 and preemptors at 1 million. Don't limit yourself with your preemption numbers or with your priority numbers. The default is for every minute a job is in the queue, it gets 1 point of priority. That's the default configuration. So keep that in mind when you're coming up with the priority numbers. Say, oh, well, I want a preemptee to be in the queue for 5 days before it even comes close to the priority of the preemptor. So you can do that pretty easily with knowing the calculation. Guaranteed preemption. This is something that we have been working on with a few sites. We now recommend it for everybody, and it will become the default. So let me explain how guaranteed preemption works. We have found that in most cases, the preemptees take a while to go away. On almost every site, preemptees take a few minutes before the epilogue has finished, before the job has cleaned itself up, and the node is ready for the preemptor. So Moab has two choices during those 5 minutes. It can wait for those resources to become available, knowing that they will become available in a certain amount of time, or you can have Moab be incredibly impatient and just say, hey, you're not preempting fast enough, I'm going to go somewhere else and preempt over here and see if they preempt faster than you did. So Moab used to behave in a very impatient sort of way. It would preempt over here. If you didn't clean up quick enough, then I'm going to go over here. And if you're not preempting quickly enough, then I'm just going to keep trying. I'm going to jump around. I'm going to cause a whole bunch of havoc on your cluster. So that's why we moved to what we call guaranteed preemption. Guaranteed preemption means that when a job has preempted another job, you're going to lock that preemptor onto the nodes that it preempted for a certain amount of time. In that case, it comes down to basically the higher of these two, job retry time and reservation retry time. So during that time, Moab is going to lock the preemptor onto those nodes. It will look each iteration. Are you done yet? Are you done yet? When it's finally done, then it'll start the job. It should be noted that in some cases there are race conditions between Moab and Tor. And that is why we have both of these retry time parameters. The job retry time says if Moab tries to start the job and Torque tells it no, don't give up, try again the next iteration. The reservation retry time means if Moab wants to start a job, but it can tell that it's not ready yet, don't give up, come around the next iteration and try again. So that's why there's those two different parameters. One is basically to account for errors from the resource manager, and the second one, reservation retry time, is to account for, I wouldn't call them internal errors, it's just basically internal race conditions where the preemptee hasn't cleaned up. Or the preemptee has cleaned up, but Torque is still seeing a very high load on the node, so Moab doesn't want to put the job there. So that's what those retry time parameters are there. So as I mentioned before, this is going to become the default behavior. If you're not using it now, I definitely recommend that you start using it. And we have found that it has solved a lot of the preemption problems that some of our earlier customers encountered. So if you tried preemption at one point and it really wasn't working for you, you may want to go back and look at guaranteed preemption. So a few questions to ask when you're setting up preemption. First off, you need to, it really comes down to site politics and policies. Who can preempt and under what conditions? How do you want the jobs to preempt each other? How long do preemptees need to clean up when you're moving them out of the way? If you can answer these 3 questions definitively for your site, you probably want to start looking at preemption. It will probably